What up, and happy Eastern. Today we're gonna have a fun one. I have here my Easter bunny, and we're gonna code Snake in arm64 assembly. Let me get my coffee. This is gonna be a longer project, so obviously the best thing that you can do is do it yourself. So keep on watching the video, play it in the background, but figure it out yourself. It's a very fun thing to do, and then come back and we can compare notes. Obviously, if you don't want to do that, we're gonna go into it, and the first thing I'm gonna do is probably show you what we're aiming for here. Let me go here. I have a demo. So if we run it, this will be the program that we're aiming for. We have the food, we have screen wrap, you can control the thing, and you're gonna get the food. It's gonna grow here, and if I'm long enough, I should be able to kill myself. No, wait, I'm gonna be able to do it. There it is, and then it finishes. Obviously, there are a lot of nuances we could do. We could add a scoreboard. We can add the only thing with the scoreboard is, I was playing around with that yesterday, is that you need to transform the score into ASCII characters. Other than that, it's not that bad. Then you could have a dying animation, a game over screen. But all of that is a lot of code bloat for what is essentially a simple thing that we want to program. And it might appear on the GitHub, which I will link then underneath, but I think for the video it's important to keep in mind what Stephen Covey once said. It's like the main thing is to keep the main thing the main thing. And the main thing here is to get something on the screen that's moving and that we can control and that has a little bit of flair to it. So this will be the version in arm64 assembly, and I think we're gonna go right into it. I have notes here, so I can look up a little bit of stuff. I do not really have internet here, so we have to wing that there a little bit, but let us go into how we're gonna do that. Also, again, if you have a question, go to the GitHub page. I will write down in the following, now before the Easter weekend, I will try to write this down and upload it. But we're gonna go in the explanation. The first thing we're gonna do is create the playing field, clear the screen, and put the snake on the screen. That's the first goal that we have to accomplish. Now, happy Eastern again. Let me open the bunny. He kept this for a year, so here we go. I don't know if it's still good, but that's what we're gonna do. So, here we go. The first thing that we're gonna do is obviously the same that we always do. We create a folder. Well, not a good idea. Snake arm64. I'm not a fan of copying stuff over, because all of a sudden it's like, oh, the watch time is less, but then you're watching the video and then all of a sudden there appears something, you have to pause and it's like unreadable. So I'm gonna type everything out, but I have my notes, so it's not completely, we're not going completely off the rails. That's the hope, at least. Okay, so as always, gonna write this, and we're gonna write, now we are in arm64 assembly. So text, global, start, create a start label here, like always, move, whatever it is now. Now it's the other way around. So in x0 we put a 23, and in x16 we have the value 1, and we do a supervised call 0x80. And today we're going to use a makefile, because we're not going to do this all the time. The Easter bunny is also painted only on one side. What a scam, man. What a scam. So vim makefile. So our source is something like snake.s. The object file object is gonna be the source. Hello, and we're typing well. And now I always forget this one. Dot s equals dot o. I think that's right. And the target is simply gonna be base name, I think. I'm gonna use snake today. Normally I like to use test, but I'm so used to this now. Base name of source. So that's that. And now we have to do the object file. So the object file, we're gonna link. The object file we're gonna link, we need the source. Of course, I didn't write a make file in a while now. So we have this, and we'll reassemble this. Assemble -arch arm64. Output is gonna be this, and the input is gonna be this. And then we're gonna put probably the target here, and that's gonna need the object file. And we're gonna link. The entry point is start. We're not gonna use anything static or the library files of macOS. We're going to need them later, but not now. Am I recording and everything? I'm so paranoid right now. Everything seems to be fine. So start, and we're gonna use the same thing. Output is $ this shit, sorry, and $ this input. Then let me do the clean. It's gonna be remove -f, the target, and we're gonna remove all the object files. So write this and let's test it. First try for makefile and the thing. Okay, we're in the game. We are in the game. It's okay. What is the first thing we're gonna do? We have to talk about this, and I had this also prepared. Well, we're gonna do two things here. There are two ways we could start. Oh, good that I did that. I have to make this full screen. Thank you for reminding me, myself. So there are two ways we can create the playing field. The first one is we create the top line, we loop through and create a top line. So basically we would do, it's 50 this, 50 insert this, and we have the top line. Then we insert this thing, we make this, and then it has to be 49 and append, and then this one. And then we would do this, and then we copy pretty much the first line and do this. And we had a few more. So that's one way to creating the playing field. We're gonna do it a little bit different, and I came to terms with that. We are going to do, we need, wait, I think 7 more. 50 insert, let me just get here to demonstrate what we're gonna do. Yeah. So let's assume we have it like this, and we're gonna initialize the memory like this. Now let me delete this, we don't need that. So let's assume we initialize the memory like this with an assembly directive, and we can go in and we just need to loop through this part here, the inner part, and we're gonna just do that. And then we have the border. So that's the first thing we're gonna do. Oh, we have a melting bunny. But there's one more thing. Happy Easter. And when we look at the playing field, we think of it like an array with a width and a height. In memory, that's of course not the case. In memory, it's just one continuous blob of memory. And in order for print it out this way, we need to add one more thing, and that is the \n character. So we're gonna do this here. Oh, now I forgot one here. Ah. Okay, not the most elegant way. Are we gonna do this? If I can even do that. So the width will be, well, the whole width for a column will be n plus 1. So in our case, I always had it like 50, so 50 plus 1 to account for this character. And then we have to make sure that we get here from the border. We're going to count here from 0. And also here, this will be the zeros column. This will be the zeros row. And then what we store for the snake will be the inner coordinates. It's not important. We come to that. It's important, but we come to that when we reach that point. So the first thing is initialize the memory, and once we have initialized it, remove the inner part and print it out. That will be our first goal now. Okay, so let's go. How do we do that? Well, the first thing is we create our data section here somewhere, and we initialize the thing. So we do that with, I call it a screen buffer, I think. Oh, I can look now. I can actually look now. Yes, I call it screen buffer. So we fill it, and we're gonna use the width times the height plus 1. So let us initialize that up here. So we have EQ. We're gonna have the width, which is gonna be 50, and we have a height. And that's gonna be 15. So now we have buffer size or something. Oh, let me check it. It's buffer size, exactly. So buffer size, and then we're gonna do that the width times the height plus, and the width plus 1 here, and that's this plus 1 here is for the \n character, and we don't need that here. Okay, so this should be fine. And then we have here, we initialize the buffer size, and the length of each character will be 1, and then we initialize it with the symbol. I have no idea what the symbol is. That's will be the symbol here, and since I cannot prove it to you because I don't have internet, we have to take my word for it. It's 0x23. That's the pound symbol. Let me check. This is for the scoreboard. We don't have that. We do just that. And now we have the symbol, and we should have, if we are going back here, then this would be if everything is filled. So at this moment we are simply at this point with the assembly directive. All right, so the first thing we need is a function name. So how do we name it? We name it initialize playing field. And then we're gonna do initializing playing field, and we're gonna do the whole function stuff. So the first thing is stop file pointer and the LR register. You use SP 16 minus 16 actually. Whoa. Minus 16. And then now I have to be careful because I did a lot of x86. We move from right to left, so we move the stack pointer in the frame pointer, and then here we're going to move the stack pointer, the frame pointer in the stack pointer, and we're going to reload FP and LR with SP and the 16 offset and return from the function. So far, nothing interesting. And okay, so the first thing we're going to do is need our screen buffer. I should have said this. I don't want to use or rely on any terminal functions that I don't have to. So we're going to create the screen buffer, and each frame we're going to print the whole thing to the frame using a syscall. That's the idea. There is a way in the terminal to say, well, go down 5 and 7 right, and then change that character and go back, and that's more in tune with the modern system. But to keep it simple and like old school, maybe we want to do it as simple as possible with the screen buffer, and we print the screen buffer each time we do one iteration of the movement. Okay, so the first thing we need is our thing. So we're going to take the screen buffer, add page, and do this here for convenience. Page off. Pave off. I don't know what I'm here. Page off. All right, so now we have the address of the buffer, and the first thing we're gonna need to do is this, enter this thing here. Yeah, or we also need that in a way. So let's define this here. We need a new line, and the new line character is, thanks to my beautiful notes. Oh, I just used this here. Okay, we are just using this. So the new line is the symbol, and now we have to think this is the width plus 1. Like here, no mistake. So we're gonna add, oh wait, let me check this here. Initialize. Because why do we have nodes if we ain't gonna use them? One new line, yes. Okay, now I have here a bunch of stuff that we don't want, but it's okay. So let's move in x10 the width, and here it's a pound, and then we take in x3, I chose here the new line character. And now width plus 1. Yeah, that was like, there's some weird stuff happening here. No, it's okay, it's correct. So store byte v3 into x0 x10. Oi. So this is this. Now the problem is we won't be seeing anything. We missed here a comma. We won't be seeing anything until we have the print playing field function. So we have that. Maybe we should write that right now. You know what? We're gonna do that right fucking now. So print playing field, because if we see something, it's always better, right? And now end print playing field. Also a little bit of boilerplate so we get into the groove of stuff. Minus 16. Move FP into SP. Stack correct, and SP into place FP, and LDP FPLR stack pointer and x16 offset, and now we are simply going to do the syscall. And I wish I wanted to show you the GitHub at this point, but I can't because I have no internet. So I'm going to show you the README in plain text. In PGU, I made this somewhere here. I think it should be here. So you're gonna look at this in plain text. So this is the syscall, and we're gonna now write a file. So we need a file descriptor, which is gonna be standard out. We need the buffer location, that's the screen buffer, and we need a buffer size, which we have declared. And then we have the syscall number 4. So let us do that, all of that. So EQ sys EQ sys write is number 4. It's still not correct here. EQ. Then we have EQ. Not EQ. We're gonna do standard out, std out, and I think that's 1. And that's that. So now where's our syscalls? Print playing field. Let me compile. Okay, we are still good. So now we're gonna move, and I have to look this up. X0 gets the file descriptor, so we move in X0 the std out. We have in X1 the buffer location, which we need here. I like to do this on top here, so let's do address page X1 screen buffer. Could I copy? Yes, I could. Do I do it? No. Why? Nobody knows. But we have the screen buffer at page off. So this is in X1, we have X0, and now we need the size in X1, buffer size in X2. X2, and the buffer size here is buffer size. So we have here simply buffer size. And then we do our syscall. Call 0x80. Compile it. We have to do this somewhere here, so we can print well, branch label, print playing field. Let's see, we should get a bunch of stuff. Invalid system call. What do you want from me? 0x80. Oh, move x16. I forgot sys out or sys write. That's kind of important. So, bang. And here we have stuff. Segmentation fault. A lot of stuff. Do I have here symbol, buffer size, and it has no ending. Well, what is the buffer size? Buffer size is width plus 1 times height. And we should only have buffer size of this stuff. Buffer size. Was this correct? Buffer size is in X2. std out is 1. That's obviously correct. Syswrite is also correct. And X1 address also correct. So let's add the new line character to see what has happened. I'm still not used to having notes, but let's go. I'm not sure if it needs a new line character. Some order buffer size is not correct. 50 and 15. There's no spelling here, and here it's also fine. So this should be all fine. So way too much. So it goes way too much. What the hell is going on here? Let me check this. Screen buffer. Buffer size 1. that I have this. Two. I'll just check. S to the out is in X0, that's correct. 2 is buffer size, is right. We have to supervise, we have this. All do I? Oh, I know, no. I see it. I don't return here. Now. And print playing field, and I have another error. Oh man, yeah, now I know the standard mistakes here that I do. Okay, so here we go. There we are. So now we have the print playing field output. This is from the assembler directive filled memory, all the pound symbol, and now we're gonna format it with the initialize snake function. That's the idea. So we put the new line, and now we're gonna store this at the with position. And yeah, we can actually just do that. And by branch label initialize playing field. Segmentation fault. Wait. Wow, yeah. This is my favorite thing here, the little pound symbol, but I have the return thing. Okay, here we are, and we have one line, and this is this one, and we have some firefighters. Okay, so let's see how wide that is, and we are spot on. This is 1, and this is 50, so 49 here, that's okay. Let me do 50 insert, and we are right here. So we are right at the 50. That's okay. So we have our first new line, and now we have to do the loop. So we keep the new line in register 3, but the next thing we're gonna do is put the empty space in another register, and then write it byte by byte in the thing. So let me make sure I use the same registers here and names. So we're gonna start. Where are we? Here. So this is the world's going down, and we are coding. So move 10, it's X10. We're gonna use with +1, and the reason we're using with +1, this +1 here, is the new line character. So this is always, we're gonna go there, and then we're gonna go down a row. So we have this, and then in X11 I had the empty space. Column empty space, and if I'm not mistaken, that's 20. Oops, oh, let's put this here. EQ empty space, and I think that's 0x20, but let me check. Empty space is 0x20. Oops. Yeah. Don't freak out on me. Okay, and here we were here. Somewhere. Okay, so now we have it, and now we need a loop counter. And I just let me check, because if the registers are so different, we are not gonna debug that wherever I have it. So loop counter is in x1. So we mode x1, and here we're gonna put a 1, and I'm gonna for once do a comment here somewhere. So somewhere here, this is outer loop counter. And then we need, what else? The row loop and the column loop. So row loop, start, and then we're gonna do end row loop somewhere here. Row loop, and then inside we will have the column loop. Column loop and end column loop. Okay, so let's think about this 1 second here. We have one thing that we always do. We know that we have the width plus 1. Again, that's for the new line character, and if we multiply that by y, we get in the row. Well, yeah, in the row. So first 0 would be the border, first row, second row, third row, fourth row, and we are always at the beginning. So if you had, for example, if y would be 4 with 0, 1, 2, 3, 4, we would be in this row, and then from here we count with x. So if we add x to it, we add on the xy position in the two-dimensional array, but again in memory it's just one continuous blob. So this is the formula that we always use. And now we have the x1, and this will be the y here. So the first thing we have to do is do the width times 1 plus x, and we have here already width plus 1 in register 10. So let's multiply x10, x10, and x1. And you check that I have this here in here. I put this in 23 for whatever reason, but for now let me keep it with that, right? And then we do the next step. We add the x to it. So we add this and the x23. So this is the result, and we add, what do we add? X. And this should be something like x2 maybe? x0. Oh yeah, sorry, x0, that's the screen buffer. So we are taking the address and adding it on. Oh man, I'm like stressed a little here. Okay. So next thing, we take the row counter. So we have x2, also a 1, and I'm gonna do, this is the inner loop counter. Not sure why we need here 20. I think that was a little stupid to do. I might change that. That's okay. So now that we have it, we are at the column, and we want to start at 1, right? Because as I said, 0 is the border, and we want to start at 1. And then we compare here. We're going to compare byte x2 with width is 50, so we're going to compare it exactly with the width. Width but we are starting at 0. Now we're starting at 1. We're going to the width, and after we are at the width, we're going to insert the border character, and no, we don't. We're going to skip the border character because we pre-initialize it, and then we're going to insert the \n character. So if we are at the width, we're going to branch equal to end column loop. Otherwise, we're going to store byte our empty space, which is in x11, or in register 11. We're going to take only the lower byte, and we're going to store it in x24, and we're going to use 1 byte, and we're going to move forward. Or we're going to not do that and just use x2, because why not? What do I do here? Yeah, we use x2, and then we're going to add, yeah, I'm like in the wrong line, and we add 1 to it. So this should be fine. And can we run it? There is a comma missing, huh? CM. Oh, we don't need to see too much mixture. Boom. And nothing. Oh, we have here 1 character here happened. x2 is 1. We add 1 because we didn't branch. So we have to say, obviously, branch to column loop. Is that aligned here? Who cares? And there we have our first row, and that seems to be correct. No, it's not. We have to go to width -1. Right, so now we have the character here. We deleted up to this point. And now that the row is over, we're going to add 1 again to x2. And now we should skip the thingy, the border. And now we're going to store strb, the, what is it? The new line character is in x3. Also at x24 and x2. I can't see anything. Okay, so this should be fine. And now obviously we have to check here that we have a comparison and end for the row loop. Let's do that. Compare, what is that? x1 to height. Also -1 on gut right now. And if it's equal, we end the row loop. Do I have this label? I do not. So let's create it somewhere here. And row loop. And oh, I have it here. Why is it? Did I end row loop? Okay, I had it already, so it's fine. So we have this, and we have an end condition. So here we can branch to. Where is the row loop? All right, let's see how this does. Does anything happen? Okay, we are not comparing x1 with height in x1. We are not counting up. Are we? Where am I? So we have to do obviously x1, and add 1. And there's a field, almost correct. The only thing we need to do here is, oh, I'm glad this worked. So the only thing we need to do here is insert one more new line character. Let me get ahead here. Are we still recording? Yes. Very pleased. I hate this part. So we can literally say, and row loop, we can store byte v3, which is the new line, and we can do that at buffer size -1. So did I do this? I just think no, it doesn't matter. Let's take here, we are pretty much done with anything, so let's take 23, x23, and move in the value buffer size -1, and then we're going to store byte at x23 that value. And of course this is not going to work, ain't it? Holy shit. Yeah. x0 buffer size -1. And that's it. We have a playing field. Okay, that's nice, and we have it. So we have the new line character. So if we go back to this picture here, and we remove this part, we have now all of this set up to, I think, 15 down. We have 50 across, and we have our new line character. So the next thing we need to do is clear the screen, and that's we're going to do one time where we use the assembly escape character. So what we're going to do is pretty much the same with the sys write call, but we're going to use the escape sequence, and the escape sequence is going to make tell the terminal, hey, clear the screen. So clear screen, and we're going to do end clear screen. We're going to store FP and LR. I was so focused to get FP and LR in the right order for this, so that that I forgot the bang. Okay, so we have this now. Move the stack pointer in the frame pointer. We move the stack pointer in the frame pointer, and LDP FPLR SP and 16, and we return. So how do we do that? Well, we do the same thing as we did with print playing field. So all of this we can take standard buffer size, no, the buffer size not. I'm gonna copy this over here, and we need the escape sequence. So let me go where data is. I don't see it here. Not there. Well, it's very nice, but the sun is a little heavy here. So we have CLS, and we're gonna do an ASCII escape sequence, and it's something with 1x1b. I have to look this up. ASCII x1b, this thing, then a big H, x1b, and a J. That's correct? Yes. So we have this, and now this x1b is escape. So this is 1, this is 2, this is 3, this is 4, this is 5, and 6. So we have a size of 6. We're gonna put here a simple 6, and now we need the address page in x1 CLS at page, and at, in case we want to move it around, x1 at page off. So let's see if this works. ASCII because there's a dot missing. So, oops, that's missing. Let's put it right there. What do you want from me? Off? Yeah, I don't know how off comes here. LDRP. LDRP, this is address P. Address P. Okay, so now we're good. Still not. What do you want from me? Huh? Oh. LDP. On the wrong line here. Okay. So we have this, and now we can branch it here. Go branch label, clear screen. And there we have it. So this is the foundation number 1. Next, we're gonna initialize the snake. Let me check we are still recording, as I'm freaking out here. Yeah, seems to be fine. Okay, so now we're gonna initialize the snake. We're gonna place it somewhere in the middle, and we have to store. Okay, yeah, now it's the time to talk about how do we store the snake. The snake is gonna be stored in a circular buffer. So we're gonna have x1, x2, y1. I mean, we can also count from 0. It doesn't matter really. Do I have this here? I had this. If we go here, and this will be on the GitHub, I have this all written out here. Also, we are in this stages now. We'll create the playing field. We draw the playing field to the screen. We clear the screen. And now we insert the snake into the screen. That's what the next thing we want to do. And I had here, is here a view mode? There is one, but I don't know the combination. Is it this? Yes. This is how we're going to store the snake. So we have x1, y1, x2, y1, all the way to all the coordinates, always in pairs. And then we're going to use a pointer for the tail and a pointer for the head. And then we're going to inch forward. That's the idea. In the circular buffer, and then we have to go around obviously once we're there. So again, for reading, this will be on the GitHub, but yeah, I don't have to explain it. As you saw now, the nicely rendered stuff here. We're gonna use that, and we're gonna initialize it. So the job now is, how do we use the coordinates? And this is important because we want to do screen wrap later. We need to, the mod function has always a weird connotation with 0, right? If you mod it, then you go to 0, but we're gonna cross that bridge later. The thing is, we want the coordinates in the real position. So I want the coordinates saved as 1, 1 for this position. And everything in the infield shall be 1, starting with 1 and not with 0. Because if I would have them all shift, then I have to reshift them at the end, and that's not very pleasant to work with. So we're gonna store the coordinates in the inner field, starting with 1. That's the idea. That's number 1, and then we're gonna place the, I lost some rabbit. And then we're gonna use the formula I put down earlier. We can always say width plus 1 times y plus x, and that's how we're gonna insert the snake symbol in the field. And then at the end of the game loop, we're gonna print out the whole thing, and then we're gonna make the snake move. But one thing after the other. So for now, we are asking ourselves why Apple does that, so we cannot. So now let's insert the snake. Well, I don't know what to do right now, so what we do is always the same thing. We write the boilerplate code. initialize snake. And we're gonna say end initialize snake. And we're gonna store fplr into on the stack. I'm gonna move the stack pointer in the frame pointer and do the reverse, right? Oops, right here. And yeah, we are in the right direction. I'm like still on x86 right now. LDP, FP, LR, SP, comma 16, and then we return. Okay, so what's the first thing we want to do? We have to load the coordinates first. We have to have, so let's actually do that. We need here coordinates. Coordinates. We don't need to fill it, but we can. With, oh, no. That was my coffee, but
maybe like paranoid. I was like,
I'm gonna. Wait a second, we're gonna do this. So that's how we handle the liquid. All right, so the first thing that we need to do is get the coordinates, and we need a head pointer and a tail pointer. So we're gonna head. There's gonna be a quad number. We're gonna initialize it to 0, and we need a tail. So that's our pointers. And how many coordinates do we need? Well, we need whatever. This has a name. We're gonna keep them small for now. Let me see how I named this. Coordinate buffer size. Very original. So coordinate buffer size. And we're gonna keep that at 2 times 25 or something for now. The 2 times is important because all coordinates are in pairs, so that has to be divisible by 2. Coordinate buffer size. One thing, and we're gonna have this with zeros. Yeah, or we can just have this 0, 0. Because we do not need this pre-initialized really. Why is everything so weird here? Yeah, that's fine. So the coordinate buffer size, so we need to initialize the head, the tail, and we have to have an initial where we want the snake. We should also have EQ initial length. That's one thing. That's gonna be something like 4. Okay. So what is the first thing we do is define where the middle is, in a way. So height divided by 2 plus minus, well, height is 15 divided by 2 is 7, right? So it will be round, it's 7.5, but it will be rounded down, so we will end up at 7. And we are counting from 0, so we probably want to add 1 there. I have to see where we are. Initialize playing field, initialize snake. So let's first, we're gonna use the correct things though. Initialize snake. Let me check. A little bigger. So yeah, initialize, we want the length. We can use the head and the tail pointer, and then we have the the height divided by 2 and width minus the initial length. Okay, let's follow this. So the first thing we're going to do is use the coordinate buffer that we now created wherever it is, right about here. Right. So where am I? Address page. Which one? X0. All good. Snake. Oh, I had this. This here all. Where is this? Screen buffer, coordinates. This is gonna be snake as a label for everything. So snake is like a struct, but not really because we don't have a size of. But we can have the same label for two things. Snake, and then we add x1, x0, and we want to have coordinates at page off. Is this 20? Why did I choose 20 here? That's okay. Oh, if you wonder, I might change a few of the registers later on the GitHub. That's like 20 is a little weird here. So let's get with the head. X1, X0, head at page off. And now we have this address of the coordinates. That's what we want to store in the head. Off. So we're going to store X20 in X1. And that's the head. I'm like a little right now. Ugh. No, that's not. No, that's the head. What am I talking about? That's correct. What am I doing here? I have the head pointer. And the head pointer, we want to store this. This is correct. And we want to store. Oh, I see. So, what we want to do. What I did here is, like I already said, we're gonna place the snake somewhere here, and so in the coordinate buffer is the pointer will be eventually 4 further down. So what I did here is I said I can immediately initialize it like that. So what I did is I move here X9, and we took 2 times the initial length. 2 times, because in the coordinate thing it will be xy, so we need 2 times that thing, and then minus 1 because we're counting from 0. So this is in x9, and then we're gonna add 2 x20, I suppose. Yep, x20, the x9 here, and then we store the x9. So now the head pointer is already pointing at the 4th position. So let me maybe, because I was confused, you don't have to. So we have x1, well, let me just do it this way. Comma paste. So this would be 3. This would be 2. Oops. This would be 2. And here would be 4. And we are at 0. Length is 4. We start at 0. Zero. So we have 1, 2, 3, 4 added, and we are here, minus 1. So here, how do I do that? Yes, like this. Here will now be the head pointer. Okay? However, the coordinates are not there yet. We are just storing the address of that point in the head thing. So it's a little, oops, here, go in the shadow. It's a little weird to do it this way, but who cares? Now, for the tail pointer, it's a little easier. You can just here use the tail and then store immediately the address 1 at address 0, the coordinate buffer at x1. Yeah. So now we have also set up here the tail pointer. The tail pointer. Hey, come back here. So the head pointer and the tail pointer set up, but we have nothing yet initialized. So there are no values in the snake that we need. So let's do that next, I guess. What did I call the loop? Nothing. I don't even know where I am. Oh, okay. Here I add 0 to 20, whatever 20 is, the coordinate buffer, and then put in 0. Adding 0, it gives nothing. We'll see how this all plays out in a moment. Now, one thing I didn't do yet, we have a direction value that's going to be important later. But we can also set this up right now. So x1, x0 direction at page off. And we're gonna put this in for direction 1 for now. Move x9, who cares at this point, the value 1. And then we're gonna store x9 at x1. Okay, so now we have the direction value. That's gonna be not important until a little bit later. But now we're gonna define the starting position. And the starting position is now, well, we have the height is, like I already said, width divided by 2. And then not the width. The height is the height divided by 2 is exactly 7. So we are in the middle of the field. And now we're going to take the width divided by 2, but then we're going to add the snake itself, which we're going to has an initial length, and we're going to subtract that as well. So that is the idea here. So x9 is going to get a value width divided by 2. I'm going to do this right here. Divided by 2 minus the initial length. And that's it. And then for x10, that is gonna get the height divided by 2, and that should be fine. Okay, so we have the snake, we have the coordinates, and now we're gonna need the screen buffer, right? Up until now, we had we have only the coordinates, and we still need the coordinates to insert them, but we have only, okay, let me recap. We took the coordinates buffer and we put the address of the beginning of the buffer in the tail, and we went 4 forward, and at the third position, so counting from 0, we pointed to that position and inserted that address in the head position. Now what we're going to do is going to loop through it and add the actual coordinates that are supposed to be on the playing field in the coordinate buffer. That's number 1. And at the same time, we are going to go on the buffer, in the screen buffer, and place symbols at that position in the screen buffer, so we see where the snake is going to start. So X3 gets the screen buffer, not move, add buffer, add page off. We have that, and now we need the symbol. This is going to be here in 4. This is going to be the symbol. Then we have in X5 I put the 0, and in 6 we have the with +1. The +1 here again is the character return. I'm like, what am I doing here? Okay. So this is with +1. We have the symbol, we have this, and now we're gonna do the calculation. So what is the calculation? Let me add a comment here. Now we're gonna do the, oh, I can see again. The width +1 times y plus x. That's the thing now. And we have our initial x and y right here. This is our x and this is our y. So what is here? X 13. Okay, whatever. We move move x 13 the x10. X10 was, oh yeah, this is here. Okay, we want to keep the height, that's fair, because we want to keep the height. We want to insert the initial height in the coordinate buffer multiple times. So now we're going to multiply, and I guess in x12 we're going to take x6, which is width, and now the x13. And now we're going to add in also in x12, yes, x12, the x9. 9, that is our width. So this is, let's check this here. X10 is height divided by 2, so this is our y here. Then we multiply it with x6, which is width times 1. So now we have this part in x12, and then we take this part and add x9, which is the x here. This is here. Why am I getting here? So we have this now. And now in x12 is the part that the offset that we need to add to the screen buffer address to insert it in the field, and that is the thing we're gonna store. And that's where we're gonna place, where we place the initial coordinate. Okay. So many words, nothing to do. So let's do it. Initialize snake loop, and then we're gonna also do this and initialize snake loop. Oh, this is for later. So I have here the loop counter. Let me identify this loop counter. So we're gonna do compare x5 with initial length. Initial length. And now branch equal to end init. Oh, whoa. Initialize snake loop. There's no code complete, a lot of vibe, and no AI. So that's the thing. Like, we go now through the 4 thingies and store it. And our thing that we calculated was 23. Move 20 into 23. Why did we do that? What was 23? 1 second here. Let me check. 20 is our coordinate buffer, and I moved that in 23. I'm not quite sure why, but why not? I mean, we do that. So now we have our coordinate buffer. Well, now it's getting cold here, and we are going to store the W9, so these values in the coordinate buffer. So we're going to store x first in x23. And we're going to look this in the debugger in a moment, because I'm not trusting, and this is a store byte. Well, this is important because we don't want to override it. And KK. And then we're gonna, oh my goodness, we're gonna take the V10. This is the Y coordinate, and we're gonna store that 1 further. So maybe for symmetry reasons we add here, and I don't know if we can do a 0. So go to 23, place in the X, and 1 further plus in the Y, and then we're gonna add, we're gonna go 2 further, and then we're gonna see what's happening. Yes, we're gonna add the 2 now, and okay, add the 9 gets, so remember, X is 9, oh, I need my jacket, I think. 1 second here, because this is too cold now. Okay. Back. What were we? Yeah, the 9 is the X9 or V9, whatever. The 9th register is the X coordinate. We're gonna go 1 forward, so we're gonna add X9 a 1. And now for the 23, we're gonna go 2 forward because we have X and Y stored in pairs. Okay, and we're gonna add 2. Oh, that is all good. And now we have, this is now, we could look at this in the debugger. Maybe we should. Are we even still compiling? No, we're not. Fill, we have a comma there. And we have tail and quad, the comma at the wrong position there. I don't know why there's a comma. And here this comma has to go. Okay, and we have unsupported, where is this? 103. The error messages never really help. Let us check here the coordinates. Move X9. Why is this so far? Move X9 with initial length. Is this spelled correctly? Initial length. I assume that's the error. And now branch equal 1 to 1. And initialize, that is a thing. Nice. And from undefined symbols, direction, undefined symbol, direction. Yeah, because there's a dot here for no reason. So we are compiling. That's exciting, but we won't see anything, and we're not even calling the function, so it doesn't really matter. Do we want to do that, or do we give it one more shot and try to print something out and then debug? I think we give it one more shot because it's Easter. So why not? Oh, 1 year old rabbit here. Okay. So register 4 has the symbol. We're gonna store it at x3. Near comma here at x3 with an offset. x3 here is the screen buffer, and the offset we calculated here is x12. So where's my mouse? Here. This was the screen buffer. Now we calculated the offset because remember, continuous block of memory. So we are going now calculating where do we want to start, somewhere here, and then we place there the symbol, which is just the pound symbol. Okay, and then we need to go forward here as well. So we're gonna add x12, and the 1, and the same for the 5. And the 5 is so we don't again go into the infinity loop here, because this is our loop counter. We add 1 and we're gonna go through the loop. And okay, so now let's test this function. Initialize snake. So, and then I'm gonna call, we have the, obviously we're gonna get a segmentation fault. Snake. Yes! So the call was correct. Now we're gonna go in the debugger and check why. I'm not even gonna bother son. Memory read failed for 0, 0. That doesn't help. Okay. Oh, then we have to do a little more here. LLDB snake. Break set at this address. And okay, so clear screen should work. He wants to do that. Okay. Let's go. We're gonna return, and now initialize the playing field. Okay, I do not want to do that. Can I go here, please? Break. Am I still recording? Yes. Break set minus address. Set minus address. We go here. No. We continue. Okay, well, that's no problem. Here's no problem. Where do you wanna add us? Where are we here now? Register read x3, screen buffer. That's okay. Compare register read x5 should be 0. It's 0. We have the compare register read x23. That's the snake. So we can immediately go here and check that. So x, let's say 32. So up until now it's all zeroed out. And now there should be a 15. Is that a good coordinate for X, and yeah, 15.7 is fine. And now we're gonna let me check what is in X3. It's the screen buffer and X12, whatever that is. Seems like a reasonable number though. And register read V4 is the 23. That's our, if you remember 23, that's the symbol. All of that is fine. When we check the X12, we add one here. I know the error. I just like, right now, let me initialize snake loop. We end initialize, well, I don't know the error, but I definitely know we didn't branch here. Realize snake loop. So that's gonna be done soon. So we return here. And here he had a problem. Print playing field. Did I have this correct? Oh, let me check. But I'm pretty sure I had my pound here. I didn't. I thought about it while writing it. And there's our snake. That's simple. So let's go back in the debuffer though. That was lucky. Okay. Wow. I think it's getting too cold here. I'm gonna check a few things. So when we go here, when we initialize the snake, you want to make sure that the coordinates are really there and that everything is set up correctly. So let us set the breakpoint, always twice. Nobody knows why. So we go in here and in register read X20, wherever 20. I will probably change that. Is the snake, and register read X1 is the head. So let's go here. X32XP. Whoa. Chill. Didn't copy the address correct. Okay, X32XP. X32XP. Take that address. We go here, and up until now there's a 0. And now register read X9. Register read X9 is a 1. Now we're gonna put in the 7. 7 because of the 2 coordinates? No. What are we doing here? Why is there 7? Frame select. X9 has a 7 and X20 has the snake address. Oh yeah. 2 coordinates, 3 lengths, 6 plus 1. So register read. Let's check that. X9 is now snake plus 7. And we're going to store that in X1. So register read X1 is in head. Position is 35. So let us go here. X32XP. Well, here's the head, and this is in little endian convention 1000434308 0A. And if we go, how do I have this? 430A. This will be the position. And what was it before? At 3, that should be where the snake starts. So it will be 3, 4, 5, 6, 7, 8, 9, A. Yeah, A. So first coordinate, second coordinate, third coordinate, fourth coordinate. I'm not quite happy with that. Okay, let us see. Wait, this is the fourth, the second, the third, and the fourth coordinate. But the head should be here. Alright? So let's check that. What are we doing now? Oh, now we are calculating the position on the board, I think. A lot of moving. Okay. So now is the moment of truth here, because this is where we store the actual values in the coordinate buffer. We looked at this a little bit, but now we didn't have a loop then. So let's take a little bit more XP and check that. So we have the 15 there already. Now we will store the 7. That's the 7. We're gonna add. We had something on the field. So now we loop and the second. So this is 16, 7. This is correct. Do another loop. And now we have 17, 7. And now we want to have the last thing stored. That's also correct. However, this should be the head address. As far as I can see. So now we should be at the end. Yeah, and now we can see this is the thing. And where was the head? Oops, Control X something. Yeah, no. There should be the head, and this is a 7. Or is this the field? I don't remember where the head was. Here. 4308. This is probably where the head is. So this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9, and this is 10. This is not correct. The head has to be right here on the X position. So this -1 here is not correct. Wait a second. Well, it's either -2. Let me check this here real fast. Yeah, no. It's initial length -1 times 2. Okay. This, now let's check this again. This is still working. Minus the snake. Initialize snake. I think that's pretty cool that we have the error here. Or not the error, it's not even an error. So, well, we caught the error early. Break set minus address. Always twice. And now let's go to the loop immediately. And loop, boop, boop, x23. Register read x23. This is where our snake is. We're here now on the 9. I think that's the head. So let's check that. exp step. There's 15.7. Now let's run through the loop. 3, 4, 5, 6, 7, 8, and 9, and we will be on the head. All right. So these are the coordinates. That's all correct. And that we have it on the field we already saw. And yeah, well, that was a good thing that we caught that early. Now let us do this. Let's run this one more time and just make absolutely sure that we are on the 9 there. And I don't know where I am. Initialize snake. We get the head, and now register read x1. We have the head, so let's check out what is there. exp. Nothing yet. So we're gonna be at the 4, so we are at the end, and now we are here and we are at 439, and the 9, as we saw, is really the point of where the head position is. So if we quit this and run it, the head here now has this position. Later we're gonna change this character so we have a real head, but that we're gonna do that when the time comes. So I think that's the thing for the first video, or for today. I don't know how I do that exactly, but we want to finish this over the Easter weekend, hopefully. The next thing is we're gonna make the preview here. So this is where we here in YouTube. Okay, so now let me go to coding, assembly, snake. No, it's capital video arm, and we are going to the second part. Oh no, we cannot show that. Or maybe we can. Now we're gonna do that, and that's what we're gonna do the next time. So not with that length, but one snake that moves across the screen. That's gonna be in the next video. All right, thank you so much. I hope you enjoy. Happy Easter again. See you in the next one.